So we're back working on this 1987 Mercedes 560 SEL with the poor heater performance problem, and I'm going to change out the portion of the water control valve, which is down here. I have it removed. There's 4 screws that you have to remove, and I have purchased just the internal solenoid portion of it here, as you can see, because this diaphragm has failed. So there's a diaphragm right there that you can see is torn, and this is the replacement one. Purchased it from a seller on eBay. So we're going to put it in and see if this fixes the lack of heat from the heater. So I've just started it now and the engine's still cold. That return pipe now is 72 Fahrenheit, and the other, gotta watch because the exhaust is directly below it, so you get a false reading. And the heater inlet pipe is 75, 73, 75. So we're going to let it run, see what the thermostat housing is. Thermostat housing is about 80 Celsius, 80 Fahrenheit, 84, 85. So we're going to run it up to temperature. So the engine's up to about 138 degrees Fahrenheit. And looking at these 2 heater hoses, that one over there, come on, focus, is about 130, and the return hose right there is 130. So we're getting good flow through the heater now. We're going to see how much heat we're getting out of it inside. Well, that's not too impressive. We're only getting about 85 to 87 degree Fahrenheit air out of the frost and the vents. It's definitely not as hot as it should be. Yeah, like 87 degrees. It's warm, but it should be much hotter than that. The controls are set to max heat, yet when I turn the controls down, it doesn't seem to change the temperature much for the max cold, and it doesn't seem to change much. So we're going to have to check that temp door, blend door, see if it's moving correctly. I can't hear any change when I turn the dial. But we got good circulation through the heater now. The engine's at 145 Fahrenheit. The thermostat hasn't opened yet. No, it hasn't opened yet. Those 2 hoses, 140 degrees on the return and 140, 35, 40 degrees on the inlet hose. So definitely there's good circulation through the heater now. Wow, that hose is hot as hell. So there's got to be a problem with the temp door, blend door inside the heater control. Well, I've been through the entire heater AC system here, and there's no description about how the temperature door functions. As I was saying, there's no description about how the temperature door functions. The air doors are controlled by vacuum, but no mention about the temperature door. So I went through the entire description and operation, so we're going to go to system diagnosis and see if there's a troubleshooting chart for poor heat. So here's symptom related diagnostic procedures. I went down the list here to see if I could find one. Insufficient cooling, outlet temperature too low with maximum heater output. So let's see what that says. Coolant level low, it's not. Engine thermostat damaged, it's not. Circulation pump not running, it is. Check circulation pump renew. Heat exchanger contaminated or damaged, well, I don't think so. Plug the thermometer into the defroster nozzles. Start the engine and run to operating temperature minimum 80. Let engine run approximately 2000 RPM for 5 minutes, then read thermometer. Should be greater than 55 C. Flush heat exchanger renew. Dual valve damaged. So they're talking about the the solenoid that I fixed already. Now I got proper heat through the heater. What about a temperature door? There's got to be some kind of temperature controlled door. How do we diagnose that? Wow. So there's this troubleshooting step for system not attaining 24 degrees Celsius. In-car sensor, temperature sensor for heat exchanger or temperature selectors are not attaining specified resistance values. So there's an in-car temp sensor and a heat exchanger temp sensor that are used to determine both the inside temperature and the temperature of the heater core. That's the only thing it makes mention of. It doesn't mention anything about the actual temperature control. What's this electronic switching unit? Unless that unit controls it itself. Renew electronic switching unit. Let's see if I can find a description of that piece. Well, this describes the overall control assembly. It talks about the temperature sensor in the heat exchanger, so we can check that. And it talks about the in-car temp sensor as well. It's above the mirror, I believe. These diagrams are absolutely terrible. Looks like they've been photocopied a million times. It doesn't mention anything about the actual control of the temperature. It talks about the temperature dial. I mean, there's got to be some method of controlling or monitoring that potentiometer as well. Let's see if I can find that control unit. Well, isn't this special? They have a nice little Mercedes-Benz AC system breakout box tester. Of course, I have that in the back cupboard, of course. Not. Well, this goes to show you how things have improved. Welcome to the 80s. The control unit used in the air conditioning system does not have onboard diagnostic capabilities and consequently does not store diagnostic trouble codes. So use the tools and techniques provided under heating and air conditioning respective component tests. In other words, you're on your own. System uses vacuum for all of the mode doors. We call it footwell, fresh air, diverter, flap, defrost, and so on. But it doesn't mention what it uses to control the temperature. So I found a hint here on one of these troubleshooting steps. Heating and air conditioning complaint operates at maximum heat only, which is the opposite of what we've got. And here it says check temperature sensors. We mentioned that. And then it says electronic switching unit for temperature control number 9 is defective. Or their supply lines sensor chain. So either the sensors or the electronic switching unit is defective. Wonder where this is. Can't tell from that diagram. It looks like it's got some kind of an electronic motor, but can't even tell where it is. Well, I'm on Identifix and looking at the system operation here. These are the same diagrams I have in AllData. There is a picture of the temperature electronic switch gear for temperature control number 9. Now I can't tell if that's on the driver's side of the dash, passenger side of the dash. I attempted to remove covers under the passenger side. It's like Houdini to get in there. Same thing with the driver's side. Looks like you got to take the console out of the vehicle. I really don't want to take the whole entire vehicle apart to find this stuff. You know, all of the tests point to that mono valve. I got good heat circulation through the heater core now, but very poor heat out of the heater assembly. Even to test that in this temp sensor for the heat exchangers behind the radio. I don't even know how to get the radio out. Looking at it doesn't look that simple, but there must be a procedure. Here's another picture. These pictures are so horrible, they've been photocopied from paper manuals from the 80s, obviously. Number 12 is the blower motor, so now is that on the driver's side or the passenger side? It's suppose if we can find the blower motor, we'll have a better idea. I'm starting to believe it's actually on the driver's side, under the driver's side of the dash. Look at this picture of the heater assembly. That's just horrible. It's not, this is all number 6 is the temp sensor for the heat exchanger. I said you can access that behind the radio. Electronic switchgear for blower control, 19. Wow. Well, I'll keep looking. Well, I finally found some information. Removal and installation of electronic switching unit. Remove cover at the right on left-hand steering vehicle. For right-hand steering cover at the left below the instrument panel. Unscrew the electronic switching unit 9 from the blower housing and disconnect the electric coupling. That is such a horrible picture, but I think it's under the passenger side of the dash now that I install the cover on the right below the instrument panel. Well, the instrument panel's on the left. I mean, I'm under the left side of the dash and I can't see a damn thing, but I can't get any trim off. Oh well. So the auxiliary coolant pump is fed power by fuse number 5 in the fuse block under the hood. I've checked that fuse, the fuse is good. I do have power to the mono valve, the black wire with the red tracer, and I'm assuming I have power to this coolant pump. It's very difficult to get to. I think I can hear it running, but I'm not 100% certain. There's a humming noise from what appears to be the pump underneath the coolant lines. This mono valve is ground side controlled. There is no ground on it right now, which would be calling for full heat. Disconnecting the power wire right here puts it in full heat mode. But the coolant pump, if it's not circulating, will not circulate coolant properly through the heater core. So we're going to investigate that coolant pump a bit more. So here's an explanation of that coolant valve they call a mono valve. It is ground side controlled, power from the fuse box, closes when ground is present. Disconnecting it, as I said, would put it in fail-safe. It says right here, if ground is not present, the valve will be open continuously, providing heat. But that's provided, of course, the pump works. So I know the mono valve has failed, and I've replaced this diaphragm inside here with an aftermarket part of questionable origin, but I don't think that's our problem now. So here's where it says the coolant pump is. There's the mono valve, so it's just to the center of the engine bay behind the false firewall, and it shows it accessible from the top. But on this vehicle, it doesn't appear to be that easy to get to. That's supposedly the lines to it. Loosen the water hoses. Now, is that it down there? And that's just a bracket? Yeah, that's just a bracket. So it's down underneath here. And then, of course, there's a firewall, a false firewall in front of this thing. I don't see what's involved in getting that false firewall out. There's a top section I've got out, which just basically gets you down to this level here. Got to find the wiring to this thing and see if we can get current flow on that. So there's another look at the mono valve, or not mono valve, the water pump. So it appears there's a small harness coming off of it. If we can find that harness, we can actually current ramp this pump and see if it's actually running. So here's a picture of that auxiliary pump. I can hear it running. When I turn the heater off, the humming stops. But that doesn't mean it's actually circulating. The heater hoses, this is the inlet hose here and this is the return hose. They're both the same temperature now. But there are 3 lines on this heater core, and I'm still not 100% certain how this valve controls the flow through the heater core. But it's a combination of this temperature valve, which is duty cycled on the ground side by the ECU in the climate control panel, and this water pump running that controls heat flow through the heater. It doesn't use a conventional water valve like most other vehicles would. Now this picture shows accessing it through that firewall. It says remove the ABS unit, which is just a control. That's out of the way. But you can't get at this. I'm going to show you what it looks like on the actual vehicle. So I've taken that center section of the firewall, the second firewall, or false firewall out. So you can actually see the mono valve here. There it is down here. And the water pump is down below that. But for the life of me, I can't see how you're supposed to access that without taking all of this stuff off around the firewall. Unless you can get at it after you remove all the heater hoses and this ABS module bracket here. Wow. So I Googled it and I found some images in Google Images of that pump. So there's one there, and that's it there. Mercedes-Benz W126, 380 SEL, SE, and 560 SEL. But I can't find anything on eBay. This one says it's on eBay. Let's visit the website and have a look. So here's a used one on eBay for $50 US. I don't like buying used parts. I mean, we have a used part now. Now I can at least see how it's designed. So the electrical harness comes off and it's got a small plug on it. So I should be able to find that plug and confirm continuity through the pump. So there's the connector right there beside the battery. The two black red wires are the power wires going to the mono valve, and then one going down to the water pump. And this wire here, this green one, or the black or green orange trace, that is the control for the water pump. So I'm going to try and get an amp clamp over that wire. There's not very much wire there, but I'm going to try. So there's the connector going down to the water pump, and I've got it hot wired with a couple of jumper wires. And if I put this jumper wire on battery positive, the pump runs, and you can hear it running. Now I wasn't getting that kind of a sound out of it, that pulsing sound. I wonder with the pump running like that if we get good heat out of the heater. Now we're going to try it. So the engine's up to about 185 degrees Fahrenheit with that auxiliary water pump wired up. We're getting about 95 degrees out of the vent here, and up on top there roughly 92, 94 degrees. So it definitely improved. So that tells me it's not the water pump, it's the controls that are causing the problem. So with that pump running with a jumper wire, you can actually hear it running, and you can hear a pulsating sound. When it's pulsating like that, I get decent heat out of the heater. But after it runs for a few minutes, it seems like it stops pulsating like that, and we get a steady hum, kind of like we'll get if I block off the supply line. It gets like that, and then the heat diminishes in the heater again. So I'm not sure if there is a problem after all with this pump. This is obviously the first one of these I've worked on, and probably the last time I'll work on one of these. So I'm at a loss as to what to call here. A water pump, auxiliary water pump. With it running like that, I'll get heat out of the heater for a few minutes, and then it diminishes after a while and goes back down to about 80. So I'm current ramping the auxiliary coolant pump here, and it's averaging at about 0.6 amps. You can hear it pulsating, and then when I restrict the coolant flow through it, it stops pulsating and stabilizes at about 6.5 or 650 milliamps. I don't believe it's supposed to be pulsating like that, but I'm not 100% certain because I have no other one to compare it to. I think I'm going to call the coolant pump on this, but God knows where I'm going to get one.